Hello everyone, welcome to CH for us. Today we'll be solving few problems related to mole concept. We'll see the first question here. Calculate the volume at STP occupied by 14 grams of nitrogen. STP here is standard temperature pressure. So we have to find the volume of 14 grams of nitrogen at STP. As they are saying it is at STP, the given conditions are at STP. Here we have to take N2 molecule. Okay, it is a gas, N2 gas. Now, is equal to how much they are asking. 1 mole of N2 gas at STP is equal to 14 into 2, right? 14 is the atomic mass of nitrogen. We have 2 atoms of nitrogen here, which is 28. So it is 28 grams, which is equal to 22.4 liters at STP. So they are asking for 14 grams of nitrogen. What is the volume? 14 into 22.4 by 28, which is equal to 11.2 liters at STP. This is the first one. Now, we have to calculate the volume occupied by 1.5 moles of carbon dioxide. Volume of 1.5 moles of carbon dioxide at STP is equal to how much? 1 mole of carbon dioxide at STP is equal to, what is the gram molecular mass? 12 plus 2 into 16, which is equal to 12 plus 32, which is equal to 44 grams, right? Which is equal to, what is the volume? 22.4 liters at STP. Now you have to find out for 1.5 moles. They have given this for 1 mole. You have to find it for 1.5 moles of CO2 at STP is equal to how many liters? 1.5 into 22.4 by 1, which is equal to 33.6 liters of volume is occupied by 1.5 moles of carbon dioxide. Now we'll see the third one. Calculate the volume of 10 to the power 21 molecules of oxygen, O2, at STP, right? You have to take O2 here, not oxygen atom. It is oxygen molecule is equal to how much? So 1 mole of O2 at STP is equal to 32 grams, which is equal to 6.022 into 10 to the power 21 molecules, which is equal to 22.4 liters. Okay, 6.022 into 10 to the power 23 molecules of oxygen is equal to 22.4 liters. Then 10 to the power 21 molecules of oxygen, 10 to the power 21 molecules of oxygen occupies how many liters? So 10 to the power 21 into 22.4 by 6.022 into 10 to the power 23. You will be getting 37.2. First you will be getting it in liters, something around 0.0372 liters you will be getting. You have to convert it into milliliters, which will be 37.2 milliliters. Okay, from liters you have to convert it into milliliters and you have to write the final answer. Okay. Two elements X and Y. They combine to form two compounds. These are two different elements. They combine to form two different compounds. First compound is XY2 and the second compound is X3Y2. Okay, this is the molecular formula. Now, 0.1 mole of XY2, 0.1 mole of XY2 weighs 10 grams. They have given the mass of 0.1 mole of XY2 and 0.05 moles of X3Y2 weighs 9 grams. See, X3Y2 weighs 9 grams. you have to calculate the atomic masses of X and Y separately. What is the atomic mass of X? What is the atomic mass of Y? You have to calculate it separately. So, from this information, what can we write? 1 mole of XY2. We don't know what is X, what element is X and what element is Y. So, we have to write just generally that 1 mole of XY2 is equal to 6.022 into 10 to the power 23 molecules, okay, which is equal to, what is the gram molecular mass? Don't know. Then they have given that 0.1 mole of XY2, it weighs 10 grams. They have given this information. Then you can easily find the gram molecular mass of 1 mole of XY2. So how do you do that? 1 into 10 by 0.1, which is equal to 100 grams. Okay, so 1 mole of XY2 is 100 grams. Then XY2 mass of XY2 is 100 grams. You can write this as X. When you add the atomic masses of one atom of X and 2 atoms of Y, then only you will be getting this gram molecular mass, right? When you add the atomic masses of the atoms present in a molecule or a given compound, only then you will be getting the gram molecular mass. So this X can be taken here plus 2Y, because we have 2 atoms of Y, gives us 100. This is equation 1. Okay. Now we will solve this X3Y2. 1 mole of X3Y2. What is its gram molecular mass? We don't know. But 0.05 moles of X3Y2, it weighs 9 grams. So how can we calculate the gram molecular mass of 1 mole of X3Y2? 1 into 9 by 0.05, which is equal to 180 grams. Okay, 1 mole of X3Y2 is 180 grams. So how do we write that? X3Y2's gram molecular mass is 180. So 3X, because we have taken 3 atoms of X plus 2 atoms of Y is equal to 180. Now this is our equation 2. Now we have to subtract equation 1 from equation 2. 1 second, I'll rub. Equation 1 from equation 2. Okay. What will be the answer? 3x plus 2y is equal to 180. That is our second equation. Minus x plus 2y is equal to 100. You have to subtract. So 3x minus x is 2x plus 2y minus 2y gets cancelled. 180 minus 100 is 80. So x is equal to 40. What is x? The atomic mass, okay, of X is equal to 40. Element X is 40. Then what is the atomic mass of Y? For that, we can take any of this equation, either first equation or second equation we can take, and X plus 2y. I am taking here the first equation. This is first equation and this is the second, right? So I will take the first equation. X is 40 plus 2y is equal to 100. 2y is equal to 60. Y is equal to 30. So therefore, atomic mass of Y is equal to 30 and atomic mass of X is 40. Okay. What is the mass of 1 mole of water? So here they are asking the mass. First one is 1 mole of water, H2O. Mass is equal to how much? 1 mole of H2O is equal to 18 grams. So the answer is 18 grams. Now the second one, you have to calculate the mass of 0.5 moles of CO2. 1 mole of CO2 is equal to 12 plus 2 into 16, which is equal to 44 grams. Okay, for 0.5 moles of CO2 is equal to how many grams? 0.5 into 44 by 1, which is equal to 22 grams. Now the third one, you have to find the mass of 2.5 moles. 2.5 moles of Cl2. 1 mole of Cl2 is equal to 35.5. What is the atomic mass of chlorine? 35.5 units. So 35.5 into 2 will be 71. 71 grams for 1 mole of Cl2. Then 2.5 moles of Cl2 is equal to how much? 2.5 into 71 by 1, which is equal to 177.5 grams. Okay. We'll see the next question. How many moles of atoms? They are asking the number of moles. Don't get confused with number of atoms. Okay. They are asking number of moles of atoms are contained in 9 grams of aluminium. So in this question you have to find out the number of moles is equal to how much. So in the first one, 9 grams of aluminium is given. 1 mole of aluminium atom is equal to 24 grams. This is the gram molecular mass. Then 9 grams of aluminium is equal to how many moles? 9 into 1 by 24, which is equal to aluminium, right? It's not 24, it's 27. 27 grams. 24 is for magnesium. 27. Then it is equal to 1 by 3. 9 1 and 9 3 are 1 by 3 moles, which is equal to 0.33 moles. Okay. Now we will see the second one. You have to find out the number of moles in 0.8 grams of iron. Iron is Fe. Is equal to how much? 1 mole of iron is equal to, iron is 26, atomic number is 26. So 56 grams is the gram atomic mass of iron. Okay. Now 0.8 grams of iron gives how many moles? 0.8 into 1 by 56, which is equal to 1 by 70 moles. Okay, 8 by 10 into 1 by 56, which is equal to 8 by 10 into 1 by 56, 1 by 70. Okay, this is how you solve it. We'll see the next question. Okay, we'll see the next question. Calculate the number of moles in 10 grams of CaCO3. They're asking us to calculate number of moles in 10 grams of CaCO3. So first, 1 mole of CaCO3 is equal to, what is the gram molecular mass of calcium carbonate here? Calcium is 40, carbon 12, 3 oxygen atoms, 16 into 3, 48. So you'll be getting 100 grams. Okay. So for 1 mole of CaCO3 it is equal to 100 grams. Then for 10 grams it is equal to how much? 10 into 1 by 100, which is equal to 0.1 mole of CaCO3 in 10 grams of CaCO3. Okay. 0.1 mole in 10 grams of CaCO3. Now the second one we'll see. This is the first one. We have to calculate the number of moles in 1 into 10 to the power 23 molecules of carbon dioxide. 1 mole of carbon dioxide is equal to, it contains how many molecules of carbon dioxide? 6.022 into 10 to the power 23 molecules of carbon dioxide. Then 10 to the power 23 molecules of carbon dioxide contains how many moles? 10 to the power 23 into 1 by 6.022 into 10 to the power 23. 10 to the power 23 gets cancelled. We will be getting 1 by 6.022, which is equal to 0.166 moles is present in 10 to the power 23 molecules of carbon dioxide. Okay. Now we'll see the next question. Which of the following weighs most? Okay, which has mass the largest? Okay, the heaviest. 50 grams of iron. They have already given the mass here. It is 50 grams. Okay, that is the mass of the first one. Now we have to calculate the mass of 5 gram atoms of nitrogen. Second one. We are solving here. Okay, second one. 5 gram atom of nitrogen. Its mass is equal to how much? 1 mole of nitrogen atom is equal to 14 grams. Okay, this is also equal to 1 gram atom. So 1 gram atom of nitrogen is equal to 14 grams. Then 5 gram atoms is equal to how much? 5 into 14 by 1, which is equal to 70. 70 grams. Okay, this is our second. This is 70 grams. Okay, first one and second one we have completed. Now the third one, we have to find the mass of 0.1 gram atom of silver. 1 mole of silver is equal to 108 grams. Okay, this is the gram molecular mass of gram atomic mass of silver atom. Okay. Now they have asked us to find the mass of 0.1 gram atom of silver. This 108 grams is of 1 gram atom. Then for 0.1 gram atom of silver is equal to how much? 0.1 into 108 by 1, which is equal to 10.8 grams. Okay, so the third one is equal to 10.8 grams. Now we have to calculate the mass of 1 into 10 to the power 23 atoms of carbon. 1 mole of carbon is equal to, they have given here, okay, in atoms, right? 6.022 into 10 to the power 23 atoms, which is equal to 12 grams. This is the gram atomic mass of carbon. They have asked us to find out the mass of 1 into 10 to the power 23 atoms of carbon. So 1 into 10 to the power 23 into 12 by 6.022 into 10 to the power 23. You will be getting 1.992 grams. Okay. So the fourth answer is 1.992 grams. So which is heavier here? It is 70 grams, which is of 5 gram atoms of nitrogen weighs the most. Okay, therefore 5 gram atoms of nitrogen weighs the most, which is equal to 70 grams. We'll see the next question. Calculate the mass of CO2 which contains, will at a time write the given. Okay, you have to calculate the mass of CO2 which contains the same number of molecules as are contained in 40 grams of oxygen. Number of molecules in 40 grams of oxygen is equal to number of molecules present in this carbon dioxide. Okay, this amount of carbon dioxide molecules, number of molecules is equal to the number of molecules in 40 grams of oxygen. So we have to find out what is the number of molecules in 40 grams of oxygen. We know that 1 mole of O2, oxygen, O2 molecule is equal to 6.022 into 10 to the power 23 molecules of oxygen, which is equal to 32 grams. Then 40 grams of oxygen contains how many molecules? 40 into 6.022 into 10 to the power 23 molecules by 32. You will be getting the answer around 7.527 into 10 to the power 23. Okay, 527 into 10 to the power 23 molecules of oxygen. Okay, so number of molecules present in CO2, In the given situation, the number of molecules present in CO2 is also equal to 7.527 into 10 to the power 23 molecules. Okay, now you have to find this number of molecules mass. You have to find the mass. We know that 1 mole of carbon dioxide is equal to 44 grams, which is equal to 6.022 into 10 to the power 23 molecules of CO2. Then for 7.527 into 10 to the power 23 molecules of CO2, how much does it weigh? So 7.527 into 10 to the power 23 into 44 by 6.022 into 10 to the power 23. You will be getting the answer 54.996 grams, okay, of CO2. You can write it as approximately 55 grams. So the mass of CO2 present here is 55 grams.